Welcome to MPT Tech Talks, where today we're talking about all things battery development and in particular battery simulation. So today we're going to be talking about how to push batteries harder using thermal simulation. And with me I've got our technical specialist of Nathan Gunter, who's an analysis engineer and been with MAHLE Powertrain for 6 years and actually joined us through our graduate scheme. So thanks Nathan.
Hi there.
So really, to start off then, why is temperature important in a battery?
So there's kind of two reasons that you would want to think about the temperature of a battery really. The first one would be safety. So the pure sense of once the battery reaches a certain temperature, it will go into thermal runaway. And at that point it just heats itself up and up and up into combustion, and obviously that's very bad for safety, for the product itself. So that's the big first one. But the second one is about the lifetime of the cells.
Okay.
So the cells need to be kept in a good temperature, not too hot, not too cold, and therefore if you go outside of that, then you can significantly shorten the lifespan of the cells and the final product itself.
So there's an ideal band of operating window for
exactly, yeah. And so depending on how hard you want to push the battery, it becomes harder and harder to stay within that band.
Yeah.
And so that's where we have to be very clever about these sort of things.
Okay, that's good. So how do we cool batteries then?
So there's two main ways that people have been cooling batteries. The first one would be to have a cooling plate, so aluminium with lots of small channels and normal coolant flowing through it, so that's a mixture of water and ethylene glycol, and that will just be in contact with some surface of the cells, and then the heat can conduct between them. That's got some problems because you've got sort of barriers in the way. You have to have this interface material that's electrically isolating. Unfortunately, that's also tending to be thermally isolating, so it gets in the way. The other broad category is immersion cooling, where you have a dielectric fluid, which is a type of oil which is electrically non-conductive, and that just that just flows all the way around the battery cells and cools every surface of them. There's extra complications and problems with that, but those are the two broad categories.
Okay, yeah. So then why do we use thermal simulation on batteries then?
So the thermal simulation side of it is just the same as with any simulation, in the sense that you're wanting to do it quicker and cheaper than physical testing. And indeed, with physical testing, you need to have the parts already, whereas simulation, you can do it long before any parts have been manufactured. And then there's also flexibility in there, that if your design is still quite unknown, you can test a variant, and then you can get all of them sort of assessed against each other and choose the best one long before you have to have made any of these parts.
Oh, that makes sense. Yeah, okay then. So how do we go about thermally simulating batteries? Okay,
so there's breakdown of the whole cell, that you have the various components that are part of it, and we simulate all of those as electrical and thermal conductors, and then we have the core of that, which is usually called the jelly roll.
Right.
And that's the bit that does the core function of the cell of retaining charge and providing current. And so we have that simulated with its thermal and electrical properties in order to have its internal resistance. And that internal resistance then changes depending on state of charge and temperature and things like that. And then from that, we then just allow the simulation to have sort of electrical inputs and simulate either steady state or transiently what the temperature ends up being.
Okay, got you. So how can battery thermal simulations fit into the whole system assessments?
Okay, so you can do something called co-simulation. So
right.
My specialism is in CFD, so Star CCM is the software. But that can link co-simulate with other software such as GT Suite. And so that allows you to better simulate the entire system, the entire vehicle as it drives around a particular speed profile and altitude profile. And then that will allow you to manage what power demands are coming from the battery, therefore what the current is, and then that trickles through, that we then have it feeding back what the temperature of the cells is, and therefore what is the resistance of the cell, and sort of, so both sides are talking to each other. And that allows us to do things like simulate the entire Nürburgring 3 laps of that as fast as you can, and see, okay, how long do we stay within those temperature bands, and you know, how bad are we having to derate towards the end, and that allows us to then sort of refine our design iterations to push it as far as we can.
And then I assume we can validate that then in our vehicle development centre later on.
Exactly, yes, yeah.
Yeah, okay. All right, thanks very much for your time, Nathan, today. It's been really good to meet you, talk to you about this. And if you want to know more about some of our simulation techniques that we can do on battery simulation, contact us on the address below. Thanks a lot.